So section 3.7, and this is the last thing we'll do in, well, it's the last part of chapter 3. Now, this is looking at areas of graphs, regions of graphs, and I'm sure you've seen similar questions on GCSE papers, and if you haven't, it doesn't take a great deal of effort. If we've got three different lines, we've got three or four different inequalities, we can draw each of those lines, so change the inequality symbol into an equal symbol. Y is equal to 2, x is equal to 5, y is equal to 3x plus 2, and x is equal to 0. Draw all those lines on, and there's these four lines here, and then the region that we want is described by those lines. The convention is, if the inequality is a strict inequality, is an exclusive inequality, you draw a dotted line. So if you get a less than or a greater than, draw a dotted line. If you get a less than or equal to or a greater than or equal to, draw a solid line. Okay, and that is then a convention that we understand, and anyone looking at that diagram should say, okay, so I'm not allowed to be on this line, it's a dotted line, but the points on this line are included in the region that we're looking at. What you may not have seen before is when we've got a curve involved, but there's nothing different there. Draw the curve as a solid curve if it's an inclusive inequality. Draw it as a dotted curve if it's an exclusive inequality. And there are a couple of tips I can give you which might help. If we are, so here's my x-axis and y-axis. First of all, get yourself a pencil. I'm going to do it in pen rather than pencil because it's easier to see on the screen, but you do it in a pencil so you can rub things out if you need to. Now, if I'm putting on, say, this line here, so let's say this is the line y equals 3x plus 2, and as it does in example 13, we're looking for, one of the constraints on the region I'm looking for is y is less than or equal to 3x plus 2. So we want to be below this line, right? We want y is less than or equal to 3x plus 2, so we want to be down here. We don't want to be up here. Now, rather than colouring in the area that you do want, cross out the area that you don't want. And again, use a pencil, so it's not a problem. And the reason to do that is when you then put the other lines on, if I'd coloured in this region down here, when I put this line in, I then have to rub out my colouring in. If I'm crossing off the areas that I don't want, then I can keep going with my remaining things, with my remaining lines, with my remaining functions, curves, whatever they are. And as I'm crossing things out, what's left is the region that I did want, okay? And then you can, you can shade that in as the final stage, or often it'll say label the region as R, but if you then come along at the last bit and then colour it in, you're not having to shade in a region and then rub it out and rub out different bits. So cross out the bits that you don't want, colour in the bits that you do want. And the last bit of advice is, if it's not obvious, usually it's obvious. If y is less than or equal to the curve, you want to be below it. If y is greater than or equal to the curve, you want to be above it. If it's not obvious, just check a point. So let's say we've got y is greater than or equal to x squared plus, so minus 3x minus 4. Well, if I draw y equals x squared minus 3x minus 4, and it looks like this. If, let's say for some reason I'm not sure whether I want this bit of my graph or this bit down here, well, check a point. Let's take a set of coordinates and substitute them in and see if they work. Now, if you're allowed to choose easy numbers, right? So the easiest numbers that we can deal with are probably 0, 0. So let's check the origins. The origin is here. 0 is greater than or equal to 0 minus 3, 0 minus 0 minus 4. Is that true? Yes, that's true. So therefore, this is the side that we want, and this is the side of the curve that we don't want, okay? And you could, just to labour the point slightly, let's say I take 0 minus 10. So let's take say I test this point on the other side of the graph. Well, that would be minus 10 is greater than or equal to 0 minus 4, and that's not true. Okay, so down here the inequality doesn't hold, up here the inequality does hold, so this is the side we want, this is the side we don't want. If the curve doesn't go through the origin, you can always use the origin as your checkpoint. If the curve does go through the origin, then the obvious thing to do again, keep the numbers simple. Check 1, 0 or 0, 1. Okay, that's as simple as the numbers we can get. As simple as we can get, keep the numbers. and that will make the arithmetic simple. If you need it, there's a trick, but most of the time it's going to be pretty obvious. If this is a greater than, you want above the curve. It's a less than, you want below the curve. Now, this section comes at the end of chapter 3, and you are used in maths to having things get harder as you go. And you might think, well, it's the end of chapter 3, but it's not particularly a hard topic. What you've got to bear in mind is that to do this, you need to be able to solve quadratic inequalities. You need to be able to find out points where quadratic curves are crossing lines. Possibly you can have two quadratics that are going to cross each other. So we're dealing with simultaneous equations in quadratics. We're dealing with everything we need to know about quadratics from chapter 2. And we might be asked to find, say, the lowest point in the region, which might be the turning point of a quadratic, and have to complete the square. So although this section doesn't have much difficult new maths in it, so far in the first 3 chapters, if they're going to set us a difficult question, it may be a shading regions question, because in order to draw the graphs in the first place, we've got to do a lot of difficult things. So this video doesn't contain many difficult bits of algebra, but in order to be able to solve the questions, you need to be able to sketch the graphs. So in this video where I've said, oh, just sketch the graph, that can be the tricky bit, or just find the crossing points. Well, that can be the tricky bit as well. Okay, that's chapter 3 dealt with.